go. So these are rational functions. When you graph them, they look kind of like that. And this is the classic rational function, 1 over x. And I'll remind you of a few things. This is called a horizontal asymptote because it's kind of like the horizon. And those, by the way, horizontals are y equals things. And if it's right on an axis, it's at 0. So it's really easy to go, wait a minute, that's the x-axis, so it should be x equals 0. No. Think about it. A spot that's here, that's x equals 1, that's x equals 2, that's x equals 3. So it can't be x equals 0. That x-axis is y equals 0. All right, and then conversely, the other one is an x equals 0 asymptote. It's the y-axis, but y on this line, y can be 0, y can be 1, y can be 2, y can be 3, so that's not y equals 0, it's x equals 0. Next, I want to get these stuck in your head. Horizontal and vertical. What I'm trying to do in my crafty way is make you associate vertical asymptotes with x things. Do you get what I'm trying to say? So if I give you asymptotes and I say x equals 2 and y equals 3, it's so easy to get confused on which one's the vertical and which one's the horizontal. But if you remember horizontal, you'll know that, oh, the y equals 1, that's the horizontal asymptote. And vertical, oh yeah, that's the x, which is the x equals lines. Those are the vertical asymptotes. Okay, so another thing we need to talk about is the domain. The domain is, and this is important to know, what the heck is the domain? It's kind of like the food. Do you get you feed functions numbers? That's what they eat. Do you get that most numbers are fine? You can stick in most numbers, but there's sometimes the function would be poisoned by a number. Just like some of you would get really sick if I gave everybody in here a peanut. Most of you would be fine, but some of you would be like really sick because you have an allergy to that specific thing. Okay, so this function right here, the domain is what you can safely feed the function, and I can feed it everything except 0. So how we write that is the domain of this function is all reals, that's a big R with 2 vertical lines making up the stem of it, okay, all reals where x cannot be 0. See, the difference here is if you just say x can't be 0, you are saying what the function can't eat. And what you're supposed to do is give the domain, which is what you can safely feed the function, which is everything except 0. It'd be like you're babysitting and you ask, like, what can I feed your kid when they get hungry tonight? And they're like, well, just anything, just don't feed her peanuts because she's got a peanut allergy. That would be a big thing to know, right? But she wouldn't just say not peanuts. The person in charge would not just say not peanuts. They would be like, well, you can feed our kid anything, but not peanuts. You got to say you can feed this function anything, just not 0. So that's how we say anything. It's just not 0. All right, let's move on to this page. So let's talk about this one. Just a second ago, I said you couldn't feed it 0, but this problem's different. This one's all reals, but x cannot be 4. That's the one thing you can't feed it. Now this next one brings up 2 things that people mess up. Number 1, they think that it's bad to feed this -1. And the reason it's okay to feed it -1 is 0 on the top is fine. You got to understand that 0 over 1 is just 0. 0 over anything is just 0. That's not a problem. It's dividing by 0 that's a problem. If I have 2 divided by 0, DNE, you know what that stands for? Does not exist. Okay. All right, so when you're making your domain and you're doing all real numbers, don't get sucked into thinking that you should put -1 on the list of things you can't feed it. X can't be 2. That one's pretty obvious. See? What's the other thing it can't be?
0.
Yes. Because if you put a 0 right there, 0 times anything, even though that comes out to -2 over there, 0 times anything is 0, and they can't have a 0 on the bottom. So a really common answer is a kid will also list in that X cannot be -1 because they think that the top shouldn't be 0. But the top can be 0, so don't put that in there. All right, and now this one, of course, it even gives you the hint right here. It has to be in factored form. And I just say it this way. From now on, for this whole class and all of next year, if you can factor something, you should. So you factor it, and then we'll talk about what you can safely feed this function. So take a second, factor it. Madeline, tell me how you have to start. I know what these are. Yep. Then you look at the signs, and you can tell by looking here, what can you tell about the signs? Plus and a minus. And then last but not least, factors of 12. And there's a lot, but take your best shot. What do you think it is? You are correct. And I want to make 4 the positive one, because I'm used to this now. I know if it comes out positive, I want the bigger one to be positive. And then to be sure, you could just multiply it all the way out, and it worked. So now we can write the domain. Everybody write the domain, and then I'll tell you quick whether you were right or not. Chase, did you start with the big R?
What?
The big R. Did you start with the big R for all reals?
Yeah.
Okay, good. And then what do I say?
I have no idea.
Okay, then what are the things that you can't feed this function because it would kill it?
0.
Nope, look here. If I stick a 0 in there and a 0 in there, it would be okay. I don't want it to equal 0, so X cannot be what? See if you can put this together. It's not 0. That's not the thing that would kill it.
-4.
There we go. Look, see, it's because if you put a -4 there, it would equal 0. And what's the other one?
3.
All right, apparently getting some help over there. But do you get this? It's just whatever would make these 0.
Yeah.
All right. Okay, so there's your domain. All right. Now, another thing that you have to understand is how to do vertical asymptotes and holes. And it says we're going to learn more about vertical asymptotes tomorrow. False. I'm going to tell you right now because I think it's easy and I think it's worth taking a second to do. The vertical, just like the domain is what you can safely feed the function. You got to know what it is. It's what you can safely feed the function. The asymptotes that are the vertical asymptotes, it's what makes the bottom 0. So what does make the bottom 0? Well, we just made a list of what makes the bottom 0. It's those things. So the vertical asymptotes are x equals -3 and x equals -4. And I get how this is confusing because this says it can't be those things.
X equals 3.
You're right, thank you. I get how that's confusing because on the one case we say not equals, because in the domain it's what you're supposed to be able to feed this function, and you can't feed it -4. And in this case it's equals, because those are lines on the graph that are dotted lines. So those are the vertical asymptotes. It's whatever makes the bottom 0. All right. Next, again, I'm giving you the big overview. I'm basically teaching you everything that we are going to learn between now and break, all today. Because then I think you'll pick up, you'll pick up most of it, and then we'll review it for the next few days. All right. So then the horizontal asymptotes, they don't even mention them here, but they're a big deal. The horizontal asymptotes are the ones that go across, right? A horizontal asymptote goes like this. All right. This is one of the hardest things to learn. So I'd like you to focus in on a new one. Everybody make this y equals 1 over x minus 5. If I just ask you the domain, super easy. Can you safely feed this function? Everything except 5, right? What about the vertical? Well, the vertical is just the thing that makes the bottom 0. So the vertical asymptote, x equals 5. Domain, what you can safely feed the function? Everything except x can't be 5 because that's an asymptote, see? And asymptotes aren't actually part of the graph. They're a place that the graph can't touch. Okay, now how about the horizontal asymptotes? I think we all know that these graphs have vertical and horizontal asymptotes. We just talked about the vertical one, and that's the up and down kind. So how do you get the horizontals? All right, let me show you what a horizontal would look like. A horizontal would look like that. And remember that the horizontals are the horizontal asymptotes. So let's say the horizontal asymptote is like 3 here. Okay, because it goes up to 3, and that's where that line is. How would you get that? If you looked at the function, which they usually look like this, or maybe they look like this, you got to ask yourself, the function will get really close to the asymptote. That's what they do. The function gets closer and closer and closer to those asymptotes. So it's really like what you're asking is, where would this function go in the long run? Like if I go way over to the right in this function, like if I go infinitely far over that way, where would it end up? Well, it would end up right at that asymptote. Okay, so what's way over there? Well, x would be like 1,000. So I call this the 1,000 idea. If you put in 1,000 for x, do you get that whatever y is when you're 1,000 places over, that's where the asymptote's going to be. It's wherever y is when you get there. Okay, so the idea is you put in 1,000 in your function. So I go over here and I go, well, if I put in 1,000, where would the y be? Well, y would equal, that's either really big like infinity or really small like 0. This one's really small, like 0. Do you agree 1,000 minus 5 is pretty much 1,000? If you had $1,000 and spent 5, yeah, you still got a lot. It's almost 1,000. So it's about 1,000. 1/1000th is tiny. If I said, here's the pizza, and we're going to share it, and I'm going to give you 1/1000th of it. Thanks, you're so generous. It'd be like a tiny speck. All right, so that's pretty much 0. So the answer is y equals 0. So you put in 1,000 and you see what you pretty much have. So it's like you're going way to the right, and when you get there, when you get way to the right, you're asking yourself, how high up has the function gotten? And this one would just be a little bit closer to 3. It'll pretty much be 3 if I go 1,000 places to the right. So let's see if you learned anything. Everybody write this down. Y equals 1 over x plus 10. I want to know the domain and the vertical asymptote and the horizontal where you use the 1,000 idea. I also tried to connect vertical and horizontal so you know which letter is which. Your verticals better be one letter and your horizontals better be the other. Three questions. Tate, pick one of them and tell me what you think the answer is.
For vertical.
Yep, but you better know what letter it is. Vertical,
X.
zertical, x equals 10. Good. Wait a minute, 10? If I actually stick 10 in, it's negative 10. It's negative 10 that will cause a problem. And so it's the vertical asymptote. And that's kind of like the domain. The domain question is, what can you safely feed this function? Sam Schmaltz, what can you safely feed this function?
All rational numbers except -10.
X cannot be -10. And technically I said real numbers, although it's very similar. So I would have probably accepted that answer just fine in the test. But I'm going to keep saying it as real numbers. There's a difference. Because rational numbers can be written as a fraction. And you can actually put in numbers that can't be written as a fraction. So stick with real. All right, horizontals. That's the 1,000 idea. Because if we go on this graph 1,000 spots to the right, we will kind of know where this function went in the long run. Like way, 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 way over to the right. Where would it be? So you put in 1,000, and the 1,000 goes here. And then you end up at y equals 1 over 1,010, which is pretty much what? 0. Y equals 0 is the asymptote.
Can we just go over 1,000 because it's like a big number, so it gets close enough?
Yes, and 1,000 isn't like a miracle number that just like works perfectly. It's just a really big number. And I don't use a million just because then it takes a lot longer to put 6 zeros there, and so. But 10 isn't really far enough to feel like you've gone way to the right.
Yeah.
So it's just a kind of a random number picked because it's big, but not so big that it's clunky to write.
So if something like this run like the SAT or SAT, we would just do over 1,000?
If you put in 1,000, it's going to tell you just as well as if you put in 10,000.
Okay.
It would still be 1 over 10,000, which is pretty much 0.
Okay.
Now, if you want to know what they're going to do in calculus, they're going to say to put in infinity. But then you have to understand the concept of 1 over infinity, which can be more confusing to me than just 1 over 1,000.
Yeah.
I can go 1 over 1,000, that's pretty much 0.
Would 1 over infinity just be infinitely small?
Yes, which is pretty much
0.
0.
Okay.
So you could put in infinity at that moment if you want to. And that's what they'll do in calculus. All right, so if I actually had to graph this thing now, that's like the last piece of the puzzle is you'll have to graph some of these. So if I had to graph this, I'm going to go back to what the original problem was just to make sure you get this had an x plus 10 down there. Then this needs asymptotes that we just figured out. The vertical's at -10. So I'm going to just make a new axis because I wrote all over that one. So this is the last melon, everybody. If you can pay attention through this and get how to graph these things, then we're done for today and I can just get you into the homework. Okay, so if I graph my vertical asymptote, that's at x is -10. That's like a dotted line that goes up and down 10 spots over. Does that make sense to you? Okay. Horizontal is like a horizon line and it's at 0. Does that make sense to you? Okay, now I have to actually put in the graph. All I have right now is the places that the graph doesn't touch. So where do I actually get some points? Your XY chart is your best friend in graphing. I've been saying that since the beginning of the semester because anytime you have to graph something, if it's on the ACT or if it's in this class or if it's in next year, I teach pre-calc too, if you just find a few dots, then you can start connecting the dots and you go, oh yeah, it's one of those graphs. I remember this. So let's get a few points. To me, the first thing that my eye gets drawn to is -10 because it is the only point that kind of won't work. So I'm going to put in -10 though. Know why? Because that's where the asymptote will be. And that's the only number that won't come out to something. If I put in -10, I don't get anything. I get the asymptote. It says so right here. Then you pick something on either side of the asymptote. See, here's my vertical asymptote, right? I need to figure out what's going on this side of it and on this side of it. So that's why we pick something on either side of -10. So like -9. And what's on the other side of -10? -11, good. So everybody put down -9 here and -11 there. And you can reverse them if you really want to, it doesn't matter. But you want something on either side of the asymptote. Okay, now I'm sticking -9 in my function. well, go back to what the function is. It's this. If I'm sticking a -9 in there, there's only one place where x is -9. I put a -9 right here. And it works out really nice. 1 over 1, which is 1. And look, it says y equals 1. There. And if I stick in -11, how about that? -11 gives you -1 on the bottom, so 1 divided by -1 is -1. And now I just have to graph those points. -9, 1 goes like right there. And -11, -1. I'm going to make this a little smaller. That was the asymptote label. So -11, -1 would be like right down here. I could have known that. This is what those graphs always look like. Know what I mean? And I could have known that it was one of those because it's just one of those except shifted 10 to the left. Doesn't that look like I shifted it 10 to the left? And its original graph was y equals 1 over x, but then I had a plus 10, which means I shift the thing 10 to the left, and that makes sense to me. All right, there. Now I've taught you almost everything that we need to know for the test, which isn't until after break. So that's the big picture, and I wanted to give you a serious honors day where we cover a lot of stuff. And if you didn't catch all of it, it's all right. Test isn't tomorrow. Test isn't the next day. Test isn't for a long time. Now, it's not on everything. There's still a few things left, but that's a lot of what you have to know. So let's actually do a couple more that are like typical homework questions. This one, don't get trapped into thinking that 2 and -4, the things on the top, those aren't what we worry about. What we worry about is what makes the bottom 0. All right, so figure out your domain. And I'm going to explain what a hole is in just a second. For right now, figure out your domain. And I'd love for you, because this is more than what the homework even wants, but I want you to be smarter than that. If you learned what I just taught you with the 1,000 rule or the 1,000 idea, you should get the horizontal. And the vertical, you should know because it's whatever makes the bottom 0. And the domain, you should know. So answer these 3 questions. And I totally get you don't know what a hole is yet, and I'll show you that in a sec. Now pause while you try these 3 questions. Okay. Vertical asymptote. It's what makes the bottom 0. Did you say x equals -4? Raise your hand if you had that right. Awesome. Next, the horizontals. The horizontals is the 1,000 trick. The 1,000 idea. If I put in 1,000 here, and 1,000 here, and 1,000 here, then couldn't I have just canceled these off in the first place? Yeah, I could have. I mean, look at them. They're the exact same thing. X plus 4 and x plus 4. They're going to be gone anyways. If you put in 1,000, they'll still cancel. So either way, they're gone. So what's the horizontal asymptote? It's y equals about 1,000. Now think about that. Do you really think there's an asymptote exactly at 1,000? No, because I could have put in a 10 million and it would be 10 million right now. Exactly. If there's an asymptote at infinity, is there even an asymptote at all? No asymptote. All right. David, I just marked you absent a second ago. Hopefully you're signed in. You can talk to me later if you want to. Okay. So, the domain. The domain is what you can safely feed this function. Well, you can feed it anything except you can't let it eat a what? A -4. Okay, so then I'd write a big R for all reals. The official way to write that is with 2 bars on the R like that. X cannot be -4. Why can't it be -4? Because there's an asymptote there. Okay. Then the last thing is what's called a hole. And I haven't explained that to you, and I'm going to explain it now. You know I said whatever makes the bottom 0 is an asymptote. If it also makes the top 0, then it moves up a level from just being an asymptote to being something else. It becomes a whole. That creates a whole at -4, because, you know, you put a -4 in, it would make the function die, comma something. All right, so if I put in a -4, well, the whole function would die, but the y value would end up at see, y is -6. That's where the whole would be. These are different than asymptotes. Asymptotes is a dotted line there. This is a very specific spot that is just punched out of your function. All right, so do you get how I got that whole? I got the whole because it's the thing that would cancel, and it's whatever the x of that is, was -4. And then how did I get the y? By sticking that -4 back into the part that didn't cancel. I put it there. And so I got y equaled -6. That's how I got that whole. Yes?
So for horizontal asymptotes, would it be safe to assume that if they have an x on the top and an x on the bottom, it's infinitely large, so no asymptote, and if they only have an x on the bottom, 0?
Okay, well, there's two kinds of asymptotes. So
For the
that's
horizontal.
such a complicated question that I would love to answer it for you, but let's just, you and me,
Yeah.
last 10 minutes, happily talk it through, but I don't want to confuse people right now. I would like everybody to go over here and write this. Y equals x over x minus 7. Can you tell me the vertical asymptote? Can you tell me the horizontal? That is the 1000 idea, because you go way to the right and you see if it ever leveled off somewhere. And last thing, I'm going to sneak this in at the very end. We'll put parentheses around this stuff, and then we're going to throw in an x plus 5. And that will cancel off, but it'll create a hole. Can you tell me where the hole would be? Pause for a second, or you try to figure out the vertical asymptote, the horizontal asymptote, 1000 trick. If I were you, I'd cancel stuff off first before I did the 1000 idea. And the hole. Okay, so verticals, zertical. That's meant to remind you it's x equals something. And it's whatever makes the bottom 0. And I totally get you would have said x equals 7 and x equals -5. But that 1 is going to upgrade and not just be a vertical asymptote. It's even more special. It's a hole at -5 comma something. I hope you figured out what. If you haven't, go ahead and do that. But the vertical was only this one. The horizontal, after these cancel, I'd put in 1000 here and 1000 here. Now I know 7 is something, but it's really not much. It's pretty much 1000 on the bottom and 1000 on the top, and that cancels, but it doesn't cancel to nothing. What's 1000 divided by 1000? 1. So y equals 1. And the whole is at -5 comma, well, I'm going to rewrite what I had after stuff canceled. I had an x over x minus 7. That's where you put the -5 in. Did you get, the negatives will cancel, 5/12. Who had 5 over 12 for their answer? You were right. Do you get how I did that? I stuck the x into the function, but only the part that was left after things canceled. All right. Now you're ahead if you understood all of that. Let's get to your homework. By find the homework that's posted for today. Numero uno. Actually, wait. We're just doing evens today. So number 2. If you already did number 1, don't worry. We might actually go back and do odds later, but for right now, tonight's homework, just evens. Who's got it pulled up? Promise if I call on you now, I won't call on you the rest of the hour. Hey, Jan, what'd you get for number 1? Or sorry, what's the problem number 2?
Equals 4 over x plus 4.
Excellent. Okay. Now in this case, I don't think they're going to ask you as much as I asked you. So tell me, what do they want you to do? I don't think they're going to ask you for the verticals and the horizontals and the holes, but what are they asking for?
For which values of x is the expression undefined?
So, in other words, what would be the one thing you couldn't feed this function?
Oh, -4.
Yep. You can't feed it a -4. So it's kind of like a funny way of asking you the domain. That's the one thing you can't feed this function. Okay? Is that it?
Yeah.
Okay. On to number 4. John Paul, would you read me number 4?
Number 4? Okay. X squared minus 81 over 3x minus 8.
All right. My gut says if you can factor it, you should. So I'm going to factor it just in case that matters. X plus 9, x minus 9. And I thought something was going to cancel, but if you read it to me as 3x minus 8, nothing factors out of that, so nothing's going to cancel. I thought something would, and then it would create a hole, but I guess they're saving that for a future assignment. So you're just ready for it if it ever does happen. So what do they want to know? What's the point?
They want to know, like we did on the other one, what the asymptote.
Okay, but be careful. Is that what they asked? Did they actually ask for the asymptote?
No, just, undefined, what makes it.
What makes it undefined?
Oh,
Well,
the bottom 0.
exactly.
It's the bottom 0.
3x minus 8. We want to make sure that it does not equal 0. It's going to be a fraction, so I'm going to take my time and solve it out. I don't want it to be 0, so I don't want 3x to be 8. Eight thirds. If you put in 8/3 right there, it would make it equal 0. So you don't want to do that. So it can't be, x can't be 8/3. Otherwise you'll kill the function. It would make it undefined. All right. If you finish up all of these and you still have time left, what I'm going to probably have you do on Monday is, for like extra practice, is to finish the odds. So just not necessarily all of them, but if you get bored because you finished all the evens, go back and do 1 and 3 and just get a little further. Be nice to later you. All right, that's all I got for you for today.